Differential equations, we need to determine whether or not the existence and uniqueness of a solution at the given points is guaranteed by our theorem. And we're going to go over that theorem. So the theorem that we need to use is that our y prime is equal to f x comma y. And this is because we're given 2 points, and this is going to be equal to x ln of y. But we need to do something with this right here for both of them. We need to take the first order differential equation. And so taking the first order differential equation is going to yield us a df dy equal to x over y. And from here, if we plug in our values, we are going to see that 1 comma 1 is guaranteed and 1 comma 0 is not guaranteed. The exclamation mark in front of it means not, but this is, you could just say isn't guaranteed. So that one is, that one isn't guaranteed. Now for this next one, it's going to be a similar process. We need to take the first order derivative and note that y in the denominator is just y negative 1, and taking the derivative of this, so all of this together, is going to be x minus 1, and then we're going to have this be multiplied by a negative 2, and then in the denominator we'll have y raised to 2. And this is equal to our df over dy. And from here, 0 comma 1, I'll actually write it down here, 0 comma 1 is guaranteed. And 1 comma 0 isn't guaranteed. And we can see this by plugging this in. If we plug these values in, we can see that since y is in the denominator, it's kind of the same problem with this one. Now, how we would go about writing this is like the following right here. So for this first one, we have x ln y is continuous and unique as long as y is greater than 0 and continuous for all x. So know that we have a problem with our y. That's the issue. And well, why can't it be just not equal to 0 like how we have on this one to the right? Well, the reason why y has to be greater than 0 is because of this ln right here. We cannot have negative numbers inside of ln, so it has to be at least 0. But since we do this part, we find that y cannot have 0, so that means it has to be greater than 0. And this next one is continuous as long as y does not equal to 0, and it's continuous for all x. So that's how we would look at this problem for A and B.